climate is described as the average of weather conditions and their changes over a long period of time, usually 35 years. The climate plays a major role in shaping the lives of people in a variety of ways. Agricultural crops, food habits of people, dress, types of houses, and even the festivals depend on the climate. India has a great variety of climate as it has in relief, that is, huge climatic variations as well as extremes of physical features. The climate of India ranges from dry desert in Rajasthan to humid climate near the sea coasts and wet climate in Meghalaya in the northeast. In this chapter we will study the following concepts: climatic regions of India, cycle of seasons, chief characteristics of monsoon, distribution of rainfall. Climate of India. Climate is described as the average of weather conditions and their changes over a long period of time, usually 35 years. The climate plays a major role in shaping the lives of people in a variety of ways. Agricultural crops, food habits of people, types of houses, and even the festivals depend on the climate. Climatic regions of India. India has as great a variety in climate as it has in relief. The climate of India ranges from dry desert type in Rajasthan to humid climate near the sea coasts and wet climate in Meghalaya in the northeast. The elements of weather such as temperature, precipitation, rainfall and snowfall, winds, altitude, etc. control the climate of a particular place or region. In the case of India, some local factors are also important to give the climate of India a tropical touch. Jet streams. These are air currents blowing in a narrow zone over the northern plains in winter. The jet streams create a low pressure zone in northern India. You are aware that air moves from high pressure to low pressure areas. The winds blowing over the Indian Ocean rush towards the northern plains in summers and are known as northwest monsoon winds. The Himalayas. The Himalayas act as a climate barrier on our northern boundary. They do not allow the monsoon winds to leave the region, nor do they allow the cold polar winds blowing over the north to enter the Indian subcontinent. The relief. Relief refers to appreciable differences in height of any terrain. The significance of relief is especially seen in two aspects of topography, such as altitude and direction of mountain ranges. Temperature plays an important role in respect of altitude. Temperature decreases with altitude. High stations like Shimla, Darjeeling, and Nainital are cooler than the plains. Ooty lies in the Nilgiris in South India is also cooler than the land below. As regards the direction of mountain ranges, the triangular shape of peninsular India splits the monsoon winds into two branches, the Bay of Bengal and the Arabian Sea. Distance from the sea. India lies at the head of the Indian Ocean. Like peninsular India, the Indian Ocean is also triangular in shape. Thus, winds blowing over the ocean can then sweep over almost the entire landmass. The monsoons are essentially oceanic winds or sea breezes on a large scale. The sea coasts such as Chennai, Mumbai, Kolkata, almost the whole of Kerala, parts of Karnataka, Odisha and Gujarat have equatable climate. Equatable climate. The equatable climate has very little difference in the temperature of day and night. Summers are not hot and winters are mild. There is also a difference between day and night temperatures. For example, Kolkata, Mumbai and Chennai. Extreme temperature. In extreme climate, summers are hot and winters are cold. There is large difference between the temperature of day and night. Seasonal reversal. At the globe, you will find that India occupies almost a central location on it. The rotation of the earth deflects the winds in the northern hemisphere from the northwest to the northeast direction, but in the southern hemisphere the winds move in the southeast direction. After crossing the equator, they are deflected in a southwest direction. Indeed, the name monsoon has been given to these winds because of the change in direction or seasonal reversal.